start with the next topic, that is Spearman's rank correlation. So Spearman rank correlation says, so now the correlation that we have done already, that is this scatter diagram. So scatter diagram, the drawback is it will again comes to subjectivity. Maybe I am reading the graph in another way, somebody else is reading the graph in the another way. So to have that same, so we have this another like mathematical calculations, and that with that like a Spearman's rank correlation. Clear? So Spearman's rank correlation deals with the first thing in this Spearman rank correlation is the data must be in the form of ordinal, order or ranks in nature. So the data must be in the form of ranks. So for example, if we want to calculate, so if we want to calculate like the Spearman rank correlation, so like suppose we'll take the example of two judgments. So maybe one judge and the another judge is judging the set of contestants, and maybe 10 contestants are coming and they are judging it. So we have to see that if the two judgments are like correlated to each other, if one is saying good to one, another is also saying good, or if it is consensus, or if it is not, or all that. So if it is like is consensus or not in a consensus, so we have to see like that thing. So in that case, we can do this Spearman rank correlation. So let's take the example and we can understand with this example only. So like suppose there will be two judge, so J1 and J2. Fine, and there will be 10 contestants A, B, C, D. Sorry. So, like there will be maybe 10 contestants who are giving like judgments for that. So, like A contestants comes and the judge one gives the rank 2 as 5, and judge 2 has given at rank 4. So then 2, 1, 3, 6, 8, 9, 10, 4. What is left is 1. And what is left now? 1, 2, 3, 4, 5, 6, 7. So this is the suppose the ranks given by the judge 1 to the 10 contestants. And then the judge 2 has given the independent judgment to these 10 contestants. So suppose A has given, judge 1 has given contestant A is the 5th rank, and J2 has given as the 4th rank to the same person. In the same way, like it is 1, maybe 3, 4 I've already done, 5, maybe again like 6, 7, 9, 10, then maybe 2, and what is left? What is left? 1, 2, 3, 4, 5, 6, 7, 8. So this will be your, so that is your like 4 to 8. So now this is the data given to you by the two judges. Now we want to analyze that if there is any relation between the two judgments or not. If they are related, if they are not related, we have to check like that particular thing. So that we can be calculated by, so in that we can use the Spearman's rank correlation. So what the Spearman rank correlation says, there is a formula for this R. So R is equal to, so R is equal to 1 minus 6 summation D square. So it is like 1 minus 6 summation D square. So 1 minus 6 summation D square divided by, and this is 1 minus is separate, so divided by it is only under this, so divided by n into n square minus 1. So that is the formula for Spearman's rank correlation, which says 1 minus 6 sigma d square divided by n into n square minus 1. Fine. So where d is the difference between the two ranks. So that is your d. So D basically means the difference between the two ranks. So judge one and judge two. So if we are calculating the D for this data, so the D is the difference between these two ranks, 5 minus this 4. So this is the difference D, individual D we have to calculate. So this is the differences we have to see. So differences basically means like what is the deviation in the two judgments. So that will be the only the symbol for like if they are different or if they are same. So these are your these values. Again, the differences of both ends. So we have to make the square of the same, as minus 6 is also a difference and plus 6 is also a difference. So that's why we have to make it positive. So we'll make it a square. So if we make it a square on this, so this will be this raised to the power 2. So this becomes your d square values. So these are all your d square values. Now you have to make the summation of all these d square values. So if you make the sum of all these is d squares, it come out to be 50. Now if you apply in the formula of r is equal to 1 minus 6 sigma d square divided by n into n square minus 1. So which will be equal to, will be dividing in the phases. So first we'll calculate 6 into sigma d square divided by. So first we'll calculate 6 sigma d square. So that will be equal to 6 multiplied by summation d square. So summation d square will be this. So this will be your 6 summation d square. So this 300 value comes for 6 summation. So for this particular part, so the answer will be like 300. So that is your 6 summation d square, that is your 300. Then comes n into n square minus 1. So here n is the number of contestants, which is 10 over here. So n is your 10 multiplied by 10 square, that is 100 minus 1, which is 99. So that becomes n into n square minus 1, which is 990. Now we have to do it like numerator divided by denominator. So that will be equal to 300 divided by 990. And whatever the answer is, that it should be 1 that should be equal to 1 minus the current answer. So the Spearman rank correlation comes out to be like 0.6969. So that means we can say there is a positive correlation between the two judgments, but not a perfect positive. It is a high positive because it's close to like 0.7. 0.6969, it is close to zero point 0.7. So we can say that there is a high degree of correlation between the two judgments, as if one is saying good to one, the other is also saying the good to the same contestant. So then we can claim that there is a high correlation between the two. So if this the advantage is like 0.7, so 0.7 shows that a high degree of correlation, a positive one. So that shows a high degree of correlation among the two, and it is like objective now. Now, if it is like we have measured the Spearman rank correlation as 0.7. So if it is me for also it is 0.7, for you also it is zero point 0.7. So we can both say the same line that they have a high correlation between the two things. So that we can have in this Spearman's rank correlation. So now if we are talking of in general, we'll change this data. What is the case of a perfect positive correlation? Logically saying, what will be the case of a perfect positive correlation? If the answer will be like, if a perfect positive correlation means if judge 1 is giving the same ranks to the contestants, judge 2 has given also the same ranks. So in that particular case, it will be like 1. So it will be 1, 1, 2, 3, or 1 second. Or if the same rank will be given by the other. So I have copied the same data. So let's suppose the same a number of ranks are given by this, the same ranks are also given by the judge 2 also. So it should be a case of perfect positive, and the answer of perfect positive is +1. So you will see that if I copy this data of the same rank 1 to the rank 2, the answer logically also comes out to be 1. So once I can paste this, so answer of this comes out to be +1 also. So logically also saying that if the two data will be the same, then the logic also says that the answer should be 1, and by formula also it also comes out to be 1, which shows the perfect positive correlation, which says that each and every value, if one is giving the same, other is also giving the same rank to the same person. So it is a case of a perfect positive correlation. Fine. What is the case when it is a perfect negative correlation? So for that, what we have to do, we have maybe change the data. So let's suppose the judge 1 has given this rank 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So like suppose the judge 1 has given this rank, and the another has given like just opposite to it. So the another person has given the rank just opposite to it, which is this one. Fine. So one has given the same person as best, another has given the worst. So in the all the reverse direction they are giving. So it is like it should be like a perfect negative. If one is saying good, another is saying bad. So it should be a case of perfect negative correlation, and the answer is also like -1. So which shows that it is a Spearman rank correlation which determines the strength of correlation between the two things. So that we can measure through this Spearman rank correlation, that how much they are like related to each other. So if they are positive, they are high positive, or if it is high negative or a medium one or whatever. So we can judge accordingly to this data. So what is the like relation of the two things in between? So that is your Spearman's rank correlation. But the priority is, or the condition here is, the data must be in like rank form. So the condition of Spearman's rank correlation is like the data must be in the form of ranks. Otherwise, we cannot proceed with. We have to first convert our maybe a rank or ordinal data into rank or interval data into a ordinal one, and then we can proceed with the calculation of the Spearman's rank correlation. But the difference between the Spearman rank correlation and the like Carl Pearson's coefficient of correlation is the only one, that is that in Spearman rank correlation the data must be in the form of ordinal, but in the Carl Pearson's coefficient of correlation the data can be like the data can take the ratios or intervals data also. So that is the difference between the interval between the Carl Pearson's coefficient and the Spearman rank. So in Spearman rank, the condition only is like we must have a ranking data, and in the other, in Carl Pearson, we can have the ratio of the interval data also. Fine. So now take the next variation in this Spearman rank correlation. Suppose this will be the data. I make the copy of the same. So this will be the data now. Now the data will be not in the form of ranks. Suppose this data will be not given in the form of ranks. We are given in the form of actual marks appeared by the student. So like the contestants are like, so the contestants are giving the marks, not our contestants are ranked, not ranked. They are given the marks. So they have a certain parameters like out of 10, out of 5. So they are given the marks by the judges, not the ranks. Fine. So the marks given by out of maybe 10, the judgment is there. So out of 10, you're out of 20, you can say out of 20, they make the judgment. So the first has given maybe 20. Out of 20, it is there. So 20, 15, 16, 18, 14, 12, 11, 10, 6, and 4. Suppose this will be the marks given by the judge 1 to the 10 contestants, and judge 2 has given like 20, 19, 12, 13, 17, 19, no, no, 14, 12, 11, 10, and maybe 8. So these are the marks given by the 12, 11, 6. We have not to remove any duplication now. So this will be the mark given by the judge too. So if we want to apply the Spearman rank correlation to this data, we cannot apply it directly because the condition is we have to first convert the data into ranks. So we can convert the marks into ranks. We have the procedure, we can convert the marks data into the rank into the ranks because we know the highest marks has the scored one, then lower, and so on.
सर एक नंबर दे दीजिए मैं नाम क्या
So that will be like, so it will be like we have to give the marks to the same, sorry, ranks to the same. So if we are giving the ranks to this, so rank 1. So rank 1 will be like, you can give to the any definition that the highest one is the scored 1 or highest one is the scored last. So but in normal tendency, we are giving the first rank to the person who has scored the highest marks. So among this, 20 is the highest. So this is your rank 1. So 20 is the one. Then we have 18, that is 2. Then after 18, we have 16. So this is your 3. This is 4. After 15, this is 14. This is 5. Then you have 6. Then 7 is this. No, 11 is also there. 1 second. We have to revise the ranking. 20 is the highest, that is 1. No, we have to give the rank to this. 1 is the highest. 20 is the highest. Then we have 18. Then we have 16. Then we have 15. Then we have 14. After 14, we have 12. Then 11. Then we have 10. Then we have 9, and then we have, this is the least, that is 10. So this is your ranks in the first. Similarly, you have to give in the ranks in the second. So if you're giving the ranks in the second, so second ranks is again, it is first, this is second, 20, 19. After 19, it will be 17. So this will be your third. Then 17, then we have, after 17, we have 14. Yes, 4. Then 14, then we have 13, then we have 12, then you have is 11, then 8, and then you have 9, and then last is 10. So in this way, you can convert this marks data into ranks. Now this is your R1 and this is your R2. Now it will be similar to the previous question. You can apply the same model. So we can apply these ranks. So now this data will remain the same as we are make the model previous. So we will copy this ranks over here. So it will give me like correlation of positive correlation of 0.745. So 0.745 will show the correlation like they have a high positive correlation between the two judges. But the condition is we have to first convert our data into ranks. Then only we can calculate the Spearman rank correlation. So without converting into ranks, we cannot find the Spearman rank correlation of the data. Fine. So now the third variation it is. We have three variations. First is the directly ranks are given to me. Second is the ranks are not given to me directly. It will be given with the marks data, and I have to convert the marks into ranks first. So that is your second variation. The third variation is this. So I'm discussing now the third variation. So let's suppose we'll copy this data. So now if we see this particular data, so there is like all the unique marks are there. So if there is no student or contestant which is having the same marks, but it can be there. It can be there like two students have scored the same marks. It is not like it is not the thing like everybody has to have a distinct marks. Maybe two students have scored 16 marks, two students have scored 14 marks. So there can be a the case like where will be a duplication of the marks are there. So let's suppose we'll change some of the data to this. So this is 20. So let's suppose this is also 20 and this is also 20. So there will be three students who have scored with the same marks. So this is 20, this is 20, and this is also 20. And suppose this is your like 12, and suppose this is also like 12. Fine. So there will be three students who have scored 20 marks and two students who have scored same 12 marks in this. Similarly, maybe in the judgment too. So this 19 and this person also has scored 19, and maybe this is the 11 and this is also like maybe 11. So now we have to calculate the Spearman's rank correlation for this kind of a data. So now we have to convert, again the first step is we have to convert this data into ranks. So now if we are converting this data into rank, the highest is 20, but there is the problem like we have 320s. Now the 320s can be like, if we can give the different ranks to the same students with the scoring the same marks, it will be like a partiality to the student, like they can claim that why we are all on the same level. Why are you giving like a one person as the first rank and the another 20 as the second rank? So they all the three will deserve the same rank. So for that, what we have to do, we have to see which three ranks are there which has the clash. So we are seeing the clash as in this 20, in this 20, and this 20. So three clashes are there. So three ranks may be 1, 2, and 3. So if we are giving the different ranks to this, so it can be like 2, 1, 2, and 3. So we'll see the average of this 1 and 2 and 3 and we'll give that average rank to all the three. Same. So that means 1 plus 2 plus 3 divided by 3. So 1 plus 2 plus 3, 6, 6 divided by 3, that is 2. So all the three will deserve the same rank, that is 2. So all the three will be given with the same rank, that is 2, 2, and 2. So these three students will deserve the same rank, which is the average of 1, 2, and 3, because there is a clash between 1, 2, and 3 ranks. So all these three students will have the deserve the same rank, that is 2 each. So 2, 2, 2. Then after 20 we have, so below than 20 we have the number like 15. So that will be now which rank? 1, 2, 3 we have already consumed in this average. So next rank is 4. Sorry. So next rank is your fourth, because 1, 2, and 3 we have already consumed. 1, 2, 3 we have already consumed in this. So next rank is your fourth. And then after 15, this will be your 5. Then after 14th, it will be 12. But again, the 12 will be 2. So there will be 12 marks. So that is the clash between 6th and 7th rank. So if we have to given the individually, then one is 6th, one is 7th. So we have to take the average of both. So 7 and 6, the average of 7 and 6 is 6.5. So 6.5 has to be given the rank to this also, and 6.5 has to be given to this also. Now next is 6 and 7 has consumed. Now next is 11. So this is your 8, and now this is your 9, and this is 10. So in that way, we have given the ranks in the form of if there is a clash in the marks. Clear? In the same way, we can calculate the rank 2. So rank 2 is, so 20 is the highest. So this is your 1. So this is 1. Then after 20, the number is like 19, but it is 2. So 2 and 3, the clash between second and third rank. So average of second and third is 2.5, and so 2.5 and 2.5. So now the next is after 19, it will be 13. So now the next rank will be 2 and 3 will be consumed. So this will be 4. So this is 5. And now next is 11. So 11 is again between the two. So which is 6th and 7th rank. So 6 and 7, the average is 6.5. So this is also 6.5. This is also 6.5. Now next is 10. So which is 6 and 7 consumed. This is 8. And this is your 9. and this is your 10. So these are your ranks now. In there is the clash of the ranks. Now the formula is also varies over here. So it is not like the same formula is there. So there is a variation in this formula. So if we'll see, I made this formula copy over here. So this is the formula. Now in this, what the change is that here the more parameters will be added. So it is like 1 minus 6 sigma d square divided by n into n square minus 1. That remains the same. But in the numerator, 6 sigma d square plus 1 by 12, and 6 is also like outside the bracket now. So it will be like 1 minus 6 sigma d square plus 1 by 12 into m into m square minus 1. I'm writing this particular case, the formula in the copy so that it will be more like, because in Excel we cannot write in the copy, so I'm showing you on that. The screen is visible, camera. So this R is equal to 1 minus 6 summation d square plus m1 into m1 square minus 1, 1 by 12 into m1 into m1 square minus 1 plus 1 by 12 into m2 square minus 1 plus 1 by 12 m3 into m3 square minus 1 and so on, divided by n into n square minus 1. So that is the formula for the Spearman rank correlation in case of the clash in the ranks. So 1 minus 6 summation d square plus 1 by 12 into m1 square minus 1 plus 1 by 12 into m2 square minus 1 plus 1 by 12 into m3 square minus 1 and so on, divided by n into n square minus 1. So where this particular factor, if you'll see in this particular formula, this factor is repeating. So 1 by 12 m1 into m1 square minus 1, this factor is repeated again and again. And so this is the correction factor, you can say, we have to add in the case of crash in the ranks. So what is this correction factor? Now we have to check that this is up to dash dash dash. So how many we have to make it the sets? So this is first set m1, m2, m3, maybe m4 also, m5 also. So how many sets we have to take? So first question that is comes in the mind, that how many sets we have to take in this. So sets is like what are the number of repetitions in there. So if I'll see in the both the data, if I'll see in the both how many repetitions are there. So there will be repetition 1 in this 20th rank. So 1. Then we have the repetitions in this 6.5, 6.52. Then we have in 2.5, 2.53. And then we have 6.5, 6.54. So we have in total of 4 clashes in the data. So we can say that we have to have a 4 sets of this M1, M2, M3 and M4. So first thing we have selected that we must have the 4 sets for this. So we come to know that there will be 4 sets, one for M1, one for M2, M3 and the last one is for M4. First thing. Second thing to judge is, so we have already know that there will be 4 sets M4 into M4 square minus 1. Now the next thing is, what is the values of this M1, M2, M3 and M4. So two things we have to judge. One is the how many number of sets, and the another one is what will be the values of this M1, M2, M3 and M4. So value will depend upon, like if I have to calculate for the M1. So M1 will be the clash between 3 ranks. So 20 is 3 times. So M1 value is 3. Then next is 12. 12 is 2 times, so M2 is 2. M3 is again 2 and M4 is also 2. Fine. So if we calculate the correction factor individually, so which will be is like, so 1 by 12. So M1 into M1 square minus 1. So M1 value for first factor is 3 multiplied by 3 square minus 1. So which is 9 minus 1, 8. So 3 into 8 divided by 12. So that is the correction factor. M1 into M1 square minus 1. So if we can say, so 3 into 3 square minus 1 divided by 12. So we can say it like 3 into 8 divided by 12, which is 2. So which is 2. So correction factor will be like m into m square minus 1. So 3 into 8 divided by 12. So that, oh, sorry. So which comes out to be 3 into 8 divided by 12 is 2. So correction factor for first it is like 12, 2. So correction factor for first it is for 3 it is 2. For 2 it is like 2 into 2 square minus 1 divided by 12. So it will be like 2 into 2 square minus 1 divided by 12. So which is 4 minus 1, 3, 6. 6 by 12 is 0.5. So correction factor it becomes, so formula, the net formula becomes 1 minus 6 summation d square. So we have to calculate first the d values. So you can check the Excel sheet. So we can check for the first the calculation of d. So d will be equal to the difference of the two ranks. So which will be equal to R1 minus R2. So this will be our individual d values. Then we have to calculate d square. So we have to make the square of this d's. So this raised to the part 2. So we can calculate the squares of these. So this is the d square values, and now we have to take the sum of all these d squares. So 42 will be your value of summation d square. So now you have to calculate 6 sigma. First, you have to calculate like internal this bracket. So sigma d square is 42 plus first correction factor is 2. First correction factor is 2, then next is 0.5, next is again 0.5, and next is again 0.5. So there will be three correction factors will be of 0.5 because three are the values of 2 each, and one is of 3, then the correction factor is 2. So now the numerator becomes this, and you have to multiply this complete into 6 because the formula is 1 minus 6 into this whole thing. So this multiply by, so 273 becomes the numerator, and then denominator will remain the same, that is 990, because again there is a 10 elements in it. So 990 is your denominator. So now you have to calculate like numerator divided by denominator, and whatever the answer comes, that is 1 minus this one. So 0.724, that will be the correlation coefficient between these two datas, which again shows a positive correlation, but we have a high positive correlation at it reached to 0.724. Fine. So in this way, we can calculate the Spearman's rank correlation, in which we have the three variations. One is the direct ranks to given to me. In this case, we are given with the direct ranks. Then the marks we have to convert it into rank, but with the distinct marks. And then we can have with the marks, but with the duplicacy of the marks or clash in the ranks. So then we have a clash. We can find that clash first, and then this correction factor has to be added to this, which is 1 by 12 m1 into m1 square minus 1, and so on. So that factor has to be added how many times the clashes are there, and the values of m1 m2 will depend upon on the thing, on that clash how many repetitions are there. So accordingly we can find this correction factor, and we can find out the numerator part by applying this formula, and we can see that result of the Spearman's rank correlation. So that is your Spearman's rank correlation. Fine. So next is your Carl Pearson's coefficient of correlation. So the next thing comes your Carl Pearson's coefficient of correlation, in which we have to do like the Carl Pearson's. So Carl Pearson's. So we'll give the heading next. That is, so Carl Pearson's coefficient of correlation deals with the direct or rank data. That is the only difference between these two. So in the Spearman rank, the name itself says we want the ranking data, but in the Carl Pearson's coefficient of correlation, we will require the direct data. We are not in the position, or not in the like to have this. So we can have directly with the Carl Pearson's coefficient with the direct or ratio or the interval data itself. So we can work on the ratio or the interval data itself. We need not to have this like the another things involved into this. So that is your Carl Pearson's coefficient of correlation. So for that we'll take again, and the correlation will always between the two variables. So if we'll have to check the correlation between more than one variable, we have to check at a time twice. So like if suppose three judges are there, J1, J2, J3. So now we have to check it like J1 versus J3, J1 versus J2, and J2 versus J3. So at a time two, we have to take to calculate the individual correlations between the two variables and so on. So in that way, we can calculate this individual like correlation coefficients. Fine. So now if we'll take the same thing, let's suppose take the same data, but now with the same data we have to calculate now the Carl Pearson's coefficient of correlation, not the Spearman rank correlation. So now the question is we have to calculate the Carl Pearson, not the correlate, not the Spearman's rank. So for that there is no need to convert the data into ranks. So in the Carl Pearson's coefficient of correlation, we can directly come up with or directly work with the ratio or the interval data. We are need not to convert it into ranks data first. Fine. So for that, this is the data given to me. So I have to apply the Carl Pearson's coefficient of correlation formula. So that formula you will see over here. So R is equal to n summation xy minus summation x summation y whole divided by n summation x square minus summation x का whole square का under the root and n summation y square minus summation y का whole square. So this is the formula for the Carl Pearson's coefficient of correlation, which says n summation xy minus summation x into summation y whole divided by n summation x square minus summation x का whole square का under root and into n summation y square minus summation y whole square का under the root. So that is the formula, and we have to find each and every value from the data, and we'll apply in this to calculate the value of R. So if you'll see this particular formula, so first we'll think we require is n. So n here is 10. So we'll require we have n value as 10. So we have n value is 10. Now next is we want, so this is your x first marks in one, this is your marks in second. So like suppose marks in stats, marks in economics. So we have two subjects, we have to check whether there is a relation between the marks in stats and marks in maths. So if I'm saying that if a student is scoring more in maths, we have scored in more in stats also. So like the same, we have to find the correlation between the two things. So for that particular thing, we can say that if this is a correlation now, x and y. So if x and y is be like, so first thing is n is 10. Now we want summation xy according to the formula. So you have to see the formula, whatever the formula says, we have to calculate that. So summation xy. So first of all, you want the multiplication of xy's. So we'll take the multiplication of xy values. So xy values, if we multiply, so it will be equal to this multiply by y.
Excuse me, sir.
Yeah.
सर हमारी क्लास है सर 3 बजे से फाइनेंस की।
Okay, 1 second. I have
Yes,
stopped the
sir,
recording.
सबकी है
1 second,
बजे।
1 second.